Hello wonderful person, this is Anton and welcome back to TRAPPIST-1. The system discovered back in February 2017 has actually provided quite a lot of unusual mysteries, and some of them we're still not really ready to answer. But there's actually a new study that may have actually created a new hope for one of the planets here. Let's talk about this and welcome to What the Math. So a very recent study published in May of 2018 and actually still not completely finished by the scientists. This is by Gabriela Suissa and David Kipping. Basically talks about the planet here known as TRAPPIST-1e. Their study is based on a statistical analysis, which is by itself based on several other studies where we actually were able to estimate and establish the radii and the masses of the planets simply looking at the interaction they have with the parent star and with each other. So first of all, let's talk about the sizes of the planets. We can establish the sizes of the planets by essentially just looking at the star itself. So let's actually zoom into it and seeing how much the actual luminosity of the star changes when one of the planets passes in front of it. This is a pretty easy way of measuring how big the planet is. But when it comes to masses, it's a little bit more difficult. I've actually previously mentioned how they did this, but they looked at the interaction of the planets with each other. They were able to actually see at how the orbital parameters of each planet changed as they essentially orbited around TRAPPIST-1, and the various variations in the orbits can be actually used to establish the mass of each of the planets. And this is actually relatively accurate. So there's only about 5% error in this prediction. So this way we were able to establish the size and the mass of each of 7 planets here. And this is actually a pretty cool way of figuring out what each of the planets is and how big it is and how massive it is. But using this, of course, we can then figure out the density of the planets, and this is where things get interesting. Using the density for each of the planets, we're able to kind of estimate of what they might actually contain on the inside. And because we were able to establish the density and potentially predict the composition of the planets, we started looking at various planetary models and try to predict what's actually inside of each planet and what it can possibly have on the surface as well. And so this new study known as TRAPPIST-1e has a large iron core, kind of gives you the actual conclusion here. Of all 7 planets, these scientists relatively accurately were able to predict that the TRAPPIST-1e planet might potentially be one of the most Earth-like planets we've discovered so far, because statistically speaking, at a minimum, its core would actually contain at least 50% or possibly even 55% of iron. Very similar to Earth. Earth is actually at a value of about 50%. At a maximum, this would be about 78%. So this particular planet has a very large iron core that actually makes it extremely Earth-like. Now, because this planet is actually a little bit farther away from the sort of outer edge of the habitable zone, it might still be a little bit on the cold side depending on the atmosphere that's present here. But nevertheless, this iron core actually gives TRAPPIST-1e chance for not just thick atmosphere, but potentially also liquid water, because if it actually does spin fast enough and if it actually has this massive iron core on the inside that's also possibly molten and circulates around the planet, this would generate big enough magnetic field to protect TRAPPIST-1e from most of the solar flares that might be coming from TRAPPIST-1. In other words, this planet might actually be sheltered from various types of radiation that red dwarfs usually create. And most importantly, this would actually create conditions necessary for, well, really life. If there's liquid water, if there is atmosphere, if there's magnetic field, and if the planet is very Earth-like in its appearance, we can kind of expect this planet to basically have relatively Earth-like conditions on the surface. Now, obviously, it would not be as bright as Earth. It would definitely not resemble Earth in many other ways, and it might actually just have a bunch of ice on the surface here, like you can see here as well. But despite all of this beautiful planet, even if it is an ice planet, might have conditions that would actually be kind of life-friendly. So, despite the lack of brightness, it might still provide enough light for simple life forms, and the ices here might actually create various conditions that could shelter life underneath the ice as well. So there's a lot of potential and a lot of possibility for this planet to be very Earth-like. And if the atmosphere is actually thicker than this, so if this atmospheric layer here is a little bit different, and we can actually just change how the atmosphere looks by, I guess, modifying colors. For one, you can totally just go and change what it looks like in terms of the actual colors. So let's make it a little bit more green, give it some green colors here, and also change the atmosphere, making it slightly more blue, I guess, so it looks a little bit Earth-like, although that's actually clouds, it's not atmosphere. But anyway, so we can kind of make it look slightly different and more Earth-like. And here, let's just close all of this, give it some more color, accelerate this, and see what it looks like. So for all we know, this actually might be one of the most Earth-like planets we've discovered. There is actually at least one more planet that has such a massive iron core that we know for a fact. And that planet is actually one of the Kepler planets. Specifically, it's Kepler 36b. And if you go to Kepler 36b, you'll discover that it possibly is also very, very similar to this as well. So let's actually go to Kepler 36 and jump to planet B. So interestingly, we still need a lot more studies to basically try to figure out what exactly is happening in TRAPPIST-1. Because it's a red dwarf, it obviously has very different conditions to Earth. It has very different conditions to our own solar system to begin with. But TRAPPIST-1 is not a very active red dwarf. And this actually gives us hope for it to be more Earth-like. So this is Kepler 36b. As you can see, temperatures here are a little bit hotter. And because of this is definitely not the Earth we're looking for. As you can see, there's a lot of lava on the surface, and we'll actually talk about this planet in one of the future videos because it is kind of cool in its own right. Well, anyway, so that's all I wanted to talk about in this video, and thank you so much for watching. If you've enjoyed this, don't forget to subscribe and maybe share this video with someone who enjoys watching space videos and wants to learn through video games. Come back tomorrow to learn maybe about Kepler 36 or maybe about some other planet that you didn't know about before. Potentially consider supporting this channel on Patreon as well. I'll see you guys tomorrow. Space out, and as always, bye bye.